Let's prepare for the first exam. We will look at reviewing Chapter 8 and Chapter 9 in today's lecture. In example 1, let's start by solving an equation. The first step is to always distribute and get rid of any parentheses that you may have. Let's start with distribution. So we have to multiply 2 times 3x, that's 6x. Then 2 times -1, that's -2. We try to line up our equal signs so our work is neat and organized. In the next line we have 17x. We'll multiply with the -3. You always distribute with the negative. -3 times 4x is -12x. -3 times -11 is a +33. Then we have to collect like terms. On the left we can add 4x and 6x together, that makes 10x, and drop down that -2. On the right we can collect the 17x and the -12x together, and that's +5x. We cannot collect like terms on either side. Now we can start adding or subtracting to both sides. Let's isolate the x first, so I'll start by subtracting 5x to both sides. This 5x and -5x cancels out. On the left we have 10x minus 5x, which is 5x. And on the right we just get a 33. The next step is to add 2 to both sides. And so this simplifies to 5x equals 35. Let's divide both sides by 5. And so this simplifies to x equals 7. This is a good answer, but we could always check our work. You could plug this back into the original equation. Every single place that you see an x, and you could ensure that this answer is correct. I'll leave that check to you, but that's a good exercise. Practice checking your work to make sure this is a good solution. In question 2, we want to isolate the absolute value symbols first. To do that, I will subtract 20 to both sides. This gives us the absolute value of 3x plus 13 is equal to a +8. Now, since this is an absolute value, we have two possibilities. Either the inside is equal to 8, or the inside part, the 3x plus 13, could be equal to -8. That's the only way that you'll get a +8 out of taking an absolute value. On the left side, we could subtract 13 to both sides to solve for x. 3x is now equal to -5. Let's divide both sides by 3. And so our first solution is x equals -5/3. For the right side, we could subtract 13 to both sides. And so we have 3x equals -21. Let's divide both sides by 3. And -21 divided by 3, that gives us 7. So our second solution is x equals -7. And our first solution is x equals -5/3. And if we enter this onto our homework, we would usually write it with a curly bracket, -5/3, comma, -7. And the order doesn't matter. In example 3, we want to solve the inequality and graph on the number line the solution. And we need to make sure we state our answer in interval notation. So let's do that. The first step is to isolate that x, get that x by itself. So we'll subtract 19 to both sides. -5x is greater than or equal to -16 minus 19 is -35. Let's divide both sides by -5. But since we divided both sides by a negative, we have to switch the direction of the sign. This means we have x is now less than or equal to negative 35 divided by negative 5 is a positive 7. So don't forget to switch the direction of the sign. This is our solution in inequality form. We need to graph it on the number line. We'll write down the 0 that's in the middle. The 7 is on the right. We have a closed circle. And we want the values of x that are less than or equal to 7, so we're going to shade to the left. And this is our graph on the number line, and we'll state our interval notation. The graph goes forever towards the left, so that's negative infinity. And it goes to 7. It includes 7, so we'll use a square bracket. Since it's a closed circle, we'll use a square bracket. In example 4, we want to solve the inequality and graph on the number line. And don't forget to state our solution in interval notation. In this example, I want to keep that x in the middle because this is considered a trap. X is trapped between two values. So we'll start by subtracting 10 from all three sides. We'll subtract 10 from all three sides. This gives me negative 24 is less than, 3x stays in the middle, less than 37 minus 10 is 27. Now I could divide all three sides by 3. And this simplifies as negative 8 is less than x, and that's less than 9. This is our inequality, but we want to graph it on the number line. Since this is a trap, we have to shade in between. So we're going to shade in between negative 8 and 9. And they're going to be both open circles because we don't have that equal sign underneath the inequality. So this is our graph. And then we'll state our solution in interval notation. It goes to the left, negative 8. It's an open circle, so we'll use a parentheses. It goes to the right 9, and again it's an open circle, so we use parentheses. So this is our interval notation. Parentheses, negative 8, comma 9 with another parentheses. In example 5, we will start by isolating the left side here. Subtract 13 to both sides. We have 6x is less than or equal to 25 minus 13. That's going to give us a 12. Let's divide both sides by 6. And so x is less than or equal to 2. This is the first part of our solution. For the right side, since we have the word or, we need to do both inequalities. We'll add 19 to both sides. And so 2x is greater than or equal to negative 7 plus 19 gives us a positive 12. Next, I can divide both sides by 2. And that gives us x is greater than or equal to 6. Now I've realized I've made a mistake. On the left side, it was just less than, so let's just fix that here. This should have been a less than symbol, and there's no equal sign. So be careful. On the left side, it should have been strictly less than 2. I accidentally used an equal sign. Now we fixed that mistake. Let's continue on. We'll draw our number line. We have a 2 and a 6. Now for the 2, this is an open circle because there is no equal sign. And for the right side here, we have a greater than or equal, so we're going to have a closed circle for that one. On the left side, we're going to have to draw an arrow facing left because it's all the values that are less than 2. And then on the 6 is going to be shaded to the right because it's all the values that are greater than or equal to 6. And so we can state our interval notation now. The graph goes forever to the left, negative infinity up to 2 with a parenthesis. It's an open circle, so we use a parenthesis. We use the union symbol between them since there's 2, and we'll use a square bracket 6, comma, infinity. So this is it. This is our interval notation. And a helpful tip is to look at your picture. The 2 is on top of the 2, the 6 is on top of the 6. The infinity is directly below each of the arrows. In example 6, we want to solve the inequality and graph on the number line. First step is to isolate the absolute value. Let's add 10 to both sides of the equation. This gives us the absolute value of 6x plus 21 is greater than or equal to 15. Now from here we're supposed to rewrite this without absolute values. So let's recall from our notes, if we have the absolute value of x is greater than or equal to 3, this can be rewritten as x is greater than or equal to 3, or x is less than or equal to negative 3. So you'll have to check your notes. This is how we correctly translate with a greater than or equal symbol into something without absolute values. That means I can rewrite 6x plus 21 as greater than or equal to 15, or I could say 6x plus 21 is less than or equal to negative 15. Let's add or subtract to both sides now. We'll subtract 21 to both sides in this case. And so 6x is greater than or equal to negative 6. Let's divide both sides by 6. And so x is greater than or equal to negative 1. So this is half our solution. For the other side, we'll do the same process. Let's subtract 21 to both sides. And so 6x is less than or equal to negative 36. Let's divide both sides by 6. And so we have x is less than or equal to negative 6. Let's graph our solution on the number line. We have a negative 6 and a negative 1. And so we'll have a closed circle for both of these. For the negative 1, it points to the right. So we'll shade to the right. And for the negative 6, it shades towards the left. So our answer in interval notation would be negative infinity, comma, negative 6. We're going to use a square bracket because it's a closed circle. Union, we have another square bracket, negative 1, and it's going to go all the way to the right towards infinity. So that's our solution. Parentheses, negative infinity, comma, negative 6. Square bracket, union, square bracket again, negative 1, comma, infinity. In example 7, again, I'll start by isolating the absolute value, getting it by itself. So we have the absolute value of 2x plus 1 is less than 15. And now we have to remember how to translate this. Let's recall the absolute value of x, if that's less than 3, would be translated into a trap. I could rewrite this as x is trapped between negative 3 and positive 3. So we can rewrite this as a trap. We can say 2x plus 1 is trapped between negative 15 and positive 15. This means I can now subtract 1 to all three sides. And so we have negative 16 is less than 2x, and that's less than 14. Let's divide all of the sides by 2. And so this simplifies as x is between negative 8 on the left and a positive 7 on the right. We could draw our number line now. They're both open circles because there's no equal sign underneath the inequality. And since this is a trap, we're going to shade it in between. And our answer in interval notation is a parentheses negative 8, comma 7 in parentheses. They're both open circles, so we use parentheses for each side. In example 8, let's factor completely. We'll ask how many terms do we have in this case, in this problem. We have 4 terms. You can see there's 4 terms. That means we have to use grouping. In the first 2 pairs, we have the common factor is x squared, so we'll factor that out to the front. We'll factor x squared out to the front, leaving us with an x minus 8. On the right side, we have a common factor of an 11, but we'll pull out a positive 11. So that leaves us a common factor of x minus 8. Since both of these has a common factor of x minus 8, we can factor that to the front. So this is x minus 8 times x squared plus 11. And that completes our question. We can go on to the next example. We have to ask the most important factoring strategy of all. The most important factoring strategy of all is the GCF. Is there a GCF? I can see that every single one of these terms is divisible by 3. So we'll start by taking out the GCF first. So I'll divide every single term here by 3, leaving us with an x squared minus 11x plus 24. Now we can't stop here because we can now ask how many terms do we have? We have 3 terms, and since there is a leading coefficient of a 1, since the leading coefficient is a 1, we'll use the diamond method. We'll write the 24 on top and the negative 11 on the bottom. What 2 numbers multiplies to get 24 but add up to get negative 11? So that's going to be a negative 3 and a negative 8. So this factors as 3. We're going to drop down that 3 to the front. And we have an x minus 3 times an x minus 8. Now if we're not sure if this is correct or not, we can FOIL it out and making sure this gives us the original polynomial back. In question 10, we have no GCF, so we can skip that. We can look at the number of terms. This has 3 terms, and the leading coefficient is a 1 again, so that means we're going to just use the diamond method. We'll put negative 14 on top and negative 5 on the bottom. What 2 numbers multiplies to get negative 14 but add up to get negative 5? So the 2 numbers are negative 7 and positive 2. So this simply factors as x minus 7 times x plus 2. In question 11, we'll ask again, is there a GCF? There doesn't appear to be a number that divides into all 3, so there's no GCF. Then we'll look at the number of terms. In this case, there's 3 terms, but the leading coefficient is a 6, so we'll have to use the AC method. For the AC method, remember you need to multiply the front times the back. 6 times 9, that's going to give us a 54. And we want to find a number that multiplies to get 54 but add up to get negative 29. And after some calculator work, I have found the numbers is 27 and 2. They both have to be negative. And so for the AC method, we have to remember we're going to split the middle. We're going to rewrite this as negative 27x minus 2x plus 9. Since we broke it into 4 terms, we can now factor by grouping. So this simplifies as, if you look at the first pair, they have a common factor of 3x. So let's take out 3x, leaving us with a 2x minus 9. On the right side, we have to factor something, so we get the same thing back, 2x minus 9. That means I need to factor out a negative 1. This leaves us with a 2x minus 9, which is great. Now we can factor this again, taking out the 2x minus 9. We have 2x minus 9 to the front, and what's left over is the 3x minus 1. So this is our factored form. It's 2x minus 9 times 3x minus 1. For question number 12, we'll start by collecting like terms. So let's start subtracting 6x to both sides. And so we have x squared plus 7x plus 25 is equal to 43. Now, in order to solve these quadratic equations, we have to rewrite it in that standard form. We want it to be ax squared plus bx plus c equals to 0. And if we could do that, we can solve it by factoring. So we can subtract 43 to both sides now. And we have x squared plus 7x minus 18 equals to 0. Since this is 3 terms, we can use the diamond method. And so this factors as 2 and 9, but we must have a negative 18. So that must be a negative 2 and a positive 9. This factors as x minus 2 times x plus 9 equals to 0. Since both of these factors are equal to 0, we can set each one separately equal to 0. And for the first case, we'll add 2 to both sides. For the second case, we'll subtract 9 to both sides. This gives us two solutions. X could be equal to 2, or x equals negative 9. In question 13, we'll have to find the LCD. And to do that, we'll have to factor each of the denominators. And you can see that you can factor this denominator as x plus 5 times x minus 4. So that's the very first step, to factor each of the denominators, and then we can build our LCD. Our LCD is x plus 5 and x minus 4. We need all of the pieces of the denominators to simplify this expression. Now what I need to do is take the LCD and multiply it to every single term. So we'll multiply it to 4 over x plus 5. We'll take the LCD again, and then we'll multiply it to 1 over x minus 4. And for the last one, we'll take x plus 5, x minus 4, times 9 over x plus 5 times x minus 4. Essentially what we did is we used the LCD to every single term in the original equation. And as you can see, x plus 5 is going to divide out. X minus 4 and x minus 4 is going to divide out. And each one of these will divide out in the right. And so we have x minus 4 times 4 left, plus x plus 5 times 1 left, and that's equal to 9. We can distribute the 4 now. So this is 4x minus 16, plus we can distribute the 1, which just gives us back x plus 5 equals 9. We can now collect like terms. 4x plus x is 5x. Negative 16 plus 5, that's going to give us a negative 11 equals 9. We can add 11 to both sides now, and that gives us 5x equals 20. Divide both sides by 5, we get x equals 4. Now this is a possible solution. You have to check your work. This is a possible solution, and if you plug in the 4 right into here and here, you will realize that there's a problem. It causes the denominator, specifically here x minus 4, to be equal to 0. and we cannot divide by 0. It is undefined. So that means x equals 4 is an extraneous solution. This is an extraneous solution. It doesn't work. And since x equals 4 was the only possible candidate, our solution is there is no solution. So if you have an equation that involves fractions, you better check to make sure it doesn't cause the denominator anywhere to be 0. We cannot divide by 0. In example 14, we'll solve this system of equation with elimination. So for the first equation, I'm going to multiply every single one of these terms by a negative 4. I'm trying to eliminate the y variable. So this gives us a negative 8x minus a 4y is equal to negative 28. And for the bottom, we're just going to copy it directly underneath here. Now we can add these two equations together. Notice that the negative 4y and the 4y cancel out. That was the intent. We're using elimination. Negative 8x plus 3x, that's negative 5x equals negative 28 plus 8 gives us negative 20. We could divide both sides by negative 5, and so x equals positive 4. This is one side of the solution. To find the other, we'll plug this into our original equation. So we have 3 times 4 plus 4y equals 8. 3 times 4, that's 12, plus 4y equals 8. I could subtract 12 to both sides now. 4y is equal to negative 4. And so we could divide both sides by 4, giving me y equals negative 1. What's our solution? Well, it's the ordered pair 4, negative 1. So this means that these two lines intersect at the point 4, negative 1. In example 15, it is set up for substitution since x is already solid 4. So we'll take this 7 minus 4y and we'll plug it into the second equation. And so this gives me 6 times the quantity 7 minus 4y minus 5y is equal to negative 45. We can distribute now. 6 times 7, that's 42. 6 times negative 4y is negative 24y. Minus 5y is equal to negative 45. Let's collect like terms. We have 42. Negative 24y and negative 5y together makes negative 29y is equal to negative 45. Let's subtract 42 to both sides. This gives us negative 29y is equal to negative 87. I could divide both sides by negative 29, and that gives us y equals positive 3. That's one side of our solution. We'll have to plug it back into the first equation here to solve for x. And that gives us x equals 7 minus 4 times 3. And if we simplify this, we have 7 minus 12. So x equals negative 5 is our second part of our solution. Let's write it as an ordered pair. The solution is negative 5, 3. For example 16, we'll have to use distribution and multiply throughout the expression. 4 times 7, that's 28. The square root of 5 times the square root of 10, that's equivalent to the square root of 50. 4 times negative 2, that's negative 8. And the square root of 5 times the square root of 35, well, we can multiply 5 times 35. And that gives us the square root of 175. Now we have to find the prime factorization of 50 and the prime factorization of 175. So let's rewrite this as 28 times the square root of 2 times 5 times 5. And for the other side here, we have the square root of 5 times 5 times 7. That's equivalent to 175. We're looking for groups of 2, so we'll circle the pairs that we have here. And so we need to multiply now 28 times 5, and we have a square root of 2 left inside. On the right, we have negative 8 times square root of 7, but this 5 will have to be multiplied with the 8. 28 times 5 is going to give us 140 root 2. Negative 8 times 5 is negative 40, and we have a square root of 7. So this is our simplified expression, 140 square root 2 minus 40 square root 7. In example 17, I have to FOIL this thing out. So let's FOIL. We have 3 times 9, which gives us 27. We have the square root of 6 times the square root of 6, which is actually just 6. So we could rewrite this as 27 times 6. Now we need to multiply 3 times negative 2, which is negative 6. Root 6 times root 8 is root 48. We have 4 times 9 now. That's going to give us negative 36. And root 8 times root 6 is again root 48. For the last multiplication, we have negative 4 times negative 2. That's a positive 8. And root 8 times root 8 is just multiplying by 8. 27 times 6 is 162. And then we could collect like radicals here. Negative 6 root 48 and negative 36 root 48 is together negative 42 root 48. And we have 8 times 8, which is just 64. We can now simplify 162 and 64. That makes 226 minus 42 root 48. Now we could break down 48 a little bit further. We can simplify that with the prime factorization. And so this could be written as 226 minus 42 root. I could break down 48 as 2 times 2 times 2 times 2 times 3. And we're looking for pairs. So we have 2 pairs of 2's. I could rewrite this as 226 minus 42 times 2 for the first pair times 2 for the second pair. Root 3. So let's simplify this finally. This is 226 minus 168 root 3. This is finally our simplified answer. We have 226 minus 168 root 3. In question 18, we need to rationalize the denominator. So what I need to do first is to simplify the radical in the bottom. Let's simplify that first. So let's look for groups of 2. We'll take the 3, divide that by 2. I have 1 remainder 1. 11, we'll divide that by 2. That's going to give me 5 remainder 1. So I could rewrite the denominator as x to the first, y to the fifth, times the square root of xy. This allows me to simplify. The y squared cancels out with 2 of these y's, leaving us 3 left down here. And one of these x's reduces with one of these x's, leaving 2 x's on the top. So this simplifies as x squared over y cubed times the square root of xy. We can now multiply the top and bottom by the square root of xy, so we can get rid of the radical in the denominator. This simplifies to x squared times the square root of xy on the top. And on the bottom, we have y cubed. And the square root of xy times another square root of xy, well, that simplifies to just xy. We can start simplifying this expression now. This is x squared times the square root of xy on the top. And in the bottom, we have y to the fourth times x. We can reduce. We have the x cancels with one of these x's up here, leaving just one x on top. And so my final answer is x times the square root of xy divided by y to the fourth. Can't simplify it any further than this because the square root of xy cannot simplify with y to the fourth. In example 19, we'll have to multiply the top and the bottom of this expression by the conjugate of the denominator. So let's use the conjugate of the denominator, which is exactly the same thing but opposite sign. So we have 4 root 7 minus 9 root 2, and we use the exact same thing on the top. Unfortunately, we have to FOIL the top out. So we'll multiply 15 times 4. That's going to give us 60. And the square root of 7 times the square root of 7, that's just multiplying by 7. 15 times negative 9 gives us negative 135. And root 7 times root 2 is the square root of 14. We'll multiply negative 8 times 4, that's negative 32. And the square root of 2 times the square root of 7, that's the square root of 14. Negative 8 times negative 9, that's a positive 72. And we have root 2 times root 2 is just 2. That's for the top. For the denominator, we're lucky we can use the shortcut. Since these are conjugates, we can use the shortcut. And so 4 times 4, that's 16. Square root of 7 times square root of 7 is just 7. 9 times negative 9 is negative 81. And root 2 times root 2 is equivalent to multiplying by 2. Let's simplify the numerator. We have 60 times 7. That simplifies to 420. I can add negative 135 and negative 32 together. That is negative 167 root 14. 72 times 2, that's 144. So let's fix that. And then 16 times 7 gives me 112. 81 times 2 is 162. We can collect like terms now. 420 plus 144, that's 564 minus 167 root 14. And in the denominator, we can do 112 minus 162, leaving us with a negative 50 in the denominator. Finally, we have reached the simplified solution. In question 20, we'll do the same process. We have to multiply the top and bottom by the conjugate of the denominator. The exact same sign, except they're opposite. Exact same thing, except they're opposite sign. So this is 10 root 15. Now the conjugate would have a plus sign instead. And 3 root 12. So we'll use the same thing on the top and the same thing on the bottom. For the top, we can use distribution. 2 times 10, that's 20. And root 3 times root 15 is root 45. 2 times 3 is 6. And root 3 times root 12, that's root 36. For the bottom, we can use the shortcut first with the first and last with the last because they're conjugates. 10 times 10, that's 100. and root 15 times root 15 is just 15. We have negative 3 times 3, which is 9, and root 12 times root 12 is just 12. Let's simplify the numerator. We can rewrite 45 as the square root of 3 times 3 times 5. And we could simplify the square root of 36, that's 6. In the denominator, we have 100 times 15, which is 1,500. 9 times 12, that's negative 108. We have a pair of 2's here, so that gives us a 60 root 5 in the numerator. And 6 times 6 is 36. 1500 minus 108 is 1,392. Now, some students might stop right here, but you can simplify further. We can check that each of these has a common factor of 12. So we can reduce this to our final answer. Dividing each of the terms by 12, I have 5 root 5 plus 3 all over 116. So this took us quite a lot of work, but just remember you have to use the conjugate of the denominator. And then at the end, don't forget to simplify if there's a common factor. For question 21, I will isolate the radical, which is already done for me. Then I can raise both sides to a power of 3. On the left, you'll have the cube root cancel out. This gives us 6x plus 5 equals 5 cubed, which is 125. We can subtract 5 to both sides now. And so 6x is equal to 120. Let's divide both sides by 6. And so my final answer is x equals 20. Now, since we cubed both sides, we don't have to check our work, but we could if we wanted to make sure we're right. So take some time and check x equals 20 is a good solution. Plug it into the original and make sure both sides of the original equation are true. In example 22, we'll start by subtracting 2 to both sides, isolating that radical. So I have the square root of x plus 28 equals x minus 2. That means I could raise both sides now to a power of 2. And so this simplifies as x plus 28 equals x minus 2 times another x minus 2. That's what it means when we're going to square something. Multiply it to itself twice. So this simplifies to x plus 28 equals, we'll have to FOIL this out. Now I trust that you can FOIL this out on your own, and you should get x squared minus 4x plus 4. Do the work, FOIL it out to ensure you get the same thing. Now we can rewrite it in standard form. Let's subtract x to both sides. We'll subtract x to both sides, and we'll also subtract 28 to both sides. This simplifies as 0 equals x squared minus 5x minus 24. And so you can easily use the diamond method to get the factored form for this. We have x minus 8 and x plus 3. So there's two possible solutions. X minus 8 could be equal to 0, or x plus 3 could be equal to 0. For the first case, you can solve for x, and x equals 8. For the second case, you can again solve for x. X could be equal to negative 3. Now you're going to have to check your work. You're going to plug it back into the original equation for each of these x's. Now why do we have to check our work? We squared both sides right here. We squared both sides, so you have to double check your work. And if you plug in x equals 8, it's going to work. It's a good solution. But if you plug in x equals negative 3, that does not work. But I want you to check in the original problem on your own that -3 does not work. In example 23, we're going to simplify each one of these. I can rewrite 243 as the product of the following. We have 3 times 3 times 3 times 3 5 times. And so we're going to have to be looking for groups of 5 in this case. So we'll take 15 divided by 5, 10 divided by 5, and 25 divided by 5. We're using the exponents. 15 divided by 5 is 3 remainder 0. 10 divided by 5 is 2 remainder 0. And 25 divided by 5 is 5 remainder 0. So I could look for my groups of 5. So we have 1 there. So that's 3. X cubed because of this 3. Y squared because of this 2. And z to the 5th because of this 5. There is no radical left inside because we have a remainder of 0 for each one of these. So that's it. It simplifies to 3x cubed y squared z to the 5th. For example 24, we'll do a similar strategy. We'll break down 108. 108 is 2 times 2 times 3 times 3 times 3. And then we'll write r cubed, s to the 11th, and t to the 12th. Since we're looking for the pairs or groups of 2, since we're talking about a square root, we'll divide each of the exponents by 2. 3 divided by 2 is 1 remainder 1. 11 divided by 2 is 5 remainder 1. And 12 divided by 2 is equivalent to 6 remainder 0. We're looking for pairs. So we have a pair of 2's and a pair of 3's. So that gives me 6 on the outside because 2 times 3 is 6. We have an r to the 1st, s to the 5th, a t to the 6th, and on the inside we have left over 1 3. We have an r to the 1st and an s to the 1st, or just rs. There is no t's left on the inside. So that's our final answer, 6r s to the 5th t to the 6th times the square root of 3rs. For question 25, I am going to do the prime factorization of each one. 12 is 2 times 2 times 3. 50 is going to be rewritten as 2 times 5 times 5. And we can rewrite 75 in the same way. This is 3 times 5 times 5. Now remember, we're looking for pairs, so let's circle the pairs. And so we can multiply 6 times 2, that gives us 12 root 3. 8 times 5, that's negative 40 root 2. And we have 9 times 5, that's 45 root 3. We could collect like radicals. 45 and 12 can be added together. And so we have 57 root 3 minus 40 root 2 is our simplified expression. For number 26, we're going to multiply this expression to itself twice because we're going to square it. So that means we just need to remember how to FOIL. And so we can multiply 2 times 2, that's 4. Root 15 times root 15 is just 15. We'll multiply 2 times negative 9, which is negative 18. And root 15 times root 3, that's root 45. We have negative 9 times 2 is negative 18. Root 3 times root 15 is, again, root 45. Negative 9 times negative 9 is a plus 81. And root 3 times root 3, that means we're just going to be multiplying by 3. 4 times 15 is 60, so we have 60. And negative 18 root 45 plus another negative 18 root 45 is negative 36 root 45. 81 times 3 is 243. And then we'll just keep simplifying. 60 plus 243, that's going to give us 303 minus 36 root, and I could break down root 45 as 3 times 3 times 5. So now we need to multiply that 36 times 3. So this is 303 minus 36 times 3 is 108 root 5. So this is our simplified expression. 303 minus 108 root 5. For example 27, we'll rewrite negative 99 as negative 1 times 99. And we could break down the square root of negative 1 as I root 99. Now what is the square root of 99? We could use the factor tree. It's 9 times 11 and 3 times 3. So we could rewrite this as I root 3 times 3 times 11. We'll circle the pairs, bring that to the front. That gives us 3I root 11. That's our solution for example 27. For example 28, we need to distribute. So for the first part, we can just remove the parentheses. We'll get 2 minus 3i. For the second part, I need to distribute that negative. This gives me negative 20 minus 8i, and then we'll simplify. Remember, we want our answer in a plus bi form. So we'll add the real parts with the real parts. We have negative 18, because 2 times negative 20 is negative 18. And negative 3i minus 8i, that's a negative 11i. We can't simplify it further than that. We have to stop here. In example 29, I'm going to have to FOIL this out. That's one way to do it. But if you check it again closely, you'll realize these two are conjugates. So we could FOIL it and get the same answer, or we could use the shortcut. The shortcut for conjugates is something that you should remember. It's the first with the first times the last with the last. 6 times 6 is 36. And 7i times negative 7i is negative 49i squared. Recall I squared equals negative 1. So I could rewrite this as 36 minus 49 times negative 1, which simplifies to 36 plus 49. And this simplifies to 85. In the last example, we will have to divide imaginary numbers. To do this, we'll need the conjugate of the denominator. So use 3 plus 5i for the conjugate of the denominator. On the top, we'll have to FOIL. These are not conjugates, so we can't use the shortcut. 4 times 3 is 12. 4 times 5i is 20i. 9i times 3 is 27i. 9i times 5i is 45i squared. For the bottom, we can use the shortcut. We can use the shortcut for conjugates. 3 times 3 is 9. And negative 5i times 5i gives us 25i squared. We'll simplify a bit. This is 12 plus 20i plus 27i is 47i. And 45i squared, this part simplifies to negative 45. In the denominator, we have 9 plus 25, because again, I squared is that negative 1. And negative 1 times negative 25 is a positive 25. 12 minus 45 is negative 33 plus 47i over, we have 9 plus 25, that gives us 34. Now we're not done yet, we have to write it in that correct form, so let's rewrite this as negative 33 over 34 plus 47 over 34i. This is the form that they're looking for in our final solution.